Okay, now we're going to be moving into dimensional analysis. Basically, it's a really big fancy term for what you guys know as being the T-charts. I'm going to show you both metric and non-metric. Alright, we're going to start off with metric. Metric is going to be anytime you see a prefix that is part of the staircase. So that's kilo, hecto, or deci, or milli, nano, etc. Alright, if you don't know it, make sure you review that stuff. Let's start off with one simple one, and then we're going to move right into a little bit more complex one. Let's say we were to tell you that, I don't know, Jane stands at 120 centimeters tall. Okay. How tall would she be? How tall is this in meters? Okay. Basically what you're going to be doing, if you want to do a conversion sequence, you're going to go from centimeters to meters. Okay. One thing to note before I even continue is make sure you review all the stuff on counting and rounding with sig figs, because I'm going to be doing all of this with significant figures. Alright, so we're starting off with centimeters and we want to end in meters. That's what we're starting with, and we want to end with meters. Okay, as you may or may not recall, if you find it necessary to cross out things as you read it through, please do so. So Jane stands at 120 centimeters. Cross that out. We know that it's going to be 120 centimeters. How tall is this in meters? Okay, we can cross that out because we know that meters is our unknown. Alright, to do this, you're going to draw your T-chart. Alright, in the first column, you're going to be putting your given information, which in this instance is going to be 120, I'm running out of space, 120 centimeters. Okay, the reason why I leave the bottom box blank is because if I were to put 100 centimeters into a fractional format, it'll be 100 centimeters over 1. But because that one on the bottom is kind of redundant, you'll more often than not see me leave it blank. Okay, now we want to convert to meters. Whenever you are given things with a prefix, as I said, it's going to be metric. Okay, we are able to convert from centimeters to meters. We can go from a non-base, has a prefix, to a base, no prefix, in one step. How do you do it? Well, use a conversion factor. It is going to be, the way you make the conversion factor is, whatever unit you want to cancel out, you put it diagonally. That is a key facet here. Alright, whatever you want to cancel, put it diagonally. So in this instance, we have centimeters to cancel, so I'll put it diagonally over here. Whatever you want to convert to goes in the opposite box. So in this instance, meters. Okay, now the general golden rule we said with regards to metric system conversions was whatever has the prefix gets the 1, okay, and the opposite box gets the actual exponent, 10 to the negative 2 in this instance. Okay, so that's how that is done. Now, how do you enter this into a calculator? I'll show you how that's done. Hopefully you guys can see this. Alright, you're going to, sorry about that, enter in 120. Alright, the key here is divide down, multiply, cross. Well, I have a 1 here, but we're going to skip all 1s because they're essentially the same number. So 120 divided by 1 times, alright, you may do either e negative 2, or what I do is 1 e negative 2. Alright, and divide by 1, we'll skip that. So enter, that gives me 1.2 meters, because your centimeters cancel out, you're left with meters. Alright, so that's pretty much how it's done. And just to double check, if you look at the original number as 120, it's an implicit number. Alright, it has no decimal point, so if you start with the 1, end with 2, that's 2 sig figs, your answer has 2 sig figs. This is perfectly fine. Okay, so hopefully you guys can see that on the calculator. I will just tilt it upwards so you can see that a little bit better. Alright, 120 times 1e negative 2 gives you 1.2. Alright, that's going to be a simple one. Let's move on to a double step conversion. Alright, let's say rather than put a word problem, I'm just going to do a quick one. Convert 603.20 microliters to, say, I don't know, decaliters. Alright, that's what the DA is, deca. Alright, conversion sequence is going to be from microliters ultimately to decaliters, but we need to Can't do this in one step, but we can just certainly go from microliters to liters in one step, and then liters to decaliters in one step, ultimately making this a double-step conversion factor problem. How do we do this? Well, start off with the T-chart. Put your given information here, 603.20 microliters. You have microliters up here, you're going to put microliters down here to cancel that out, converting to liters. That's the first conversion right here. Going from microliters to liters, that's this conversion right here. 1 goes with the micro is 10 to the negative 6. Alright, so therefore the microliters cancel out. We're currently at liters. Okay, we've basically reached this point here. We need to do one more conversion, go from liters to decaliters, which is this step right here. The way I do that is cancel out the liters, put it down here, put decaliters up here. This gets the 1 now because as a prefix, deca is 10 to the first. Alright, you'll see that the liters now cancel out. I'm left with decaliters, which is what I want. Okay, now take a look at how I'm going to enter this in the calculator. It is going to be, hopefully I don't cover that up, 603.20, alright, times 1e negative 6 divided by 1e1. Enter. It's going to be, the answer here now, take a look, is 6.032 times 10 to the negative 5th. Okay. Now when you look at this, alright, I'll just write it out here, 6.032 e negative 5. Okay. When you look at this number here, you should note that this only has 4 sig figs here. Your answer had in fact 5, so I'm going to make this into 5 by adding a 0. Now some of you might be thinking, can you just randomly add zeros? Well, yes and no. Alright, your calculator considers this to be a sheer number, but we know that significant figures deals with measurements, and the place values in terms of a measurement will tell you how accurate the instrument is. So net, I'm not saying that you can just add zeros nilly-willy wherever you want, whenever you want, but in this instance I will add a 0 to reflect the accuracy of the instrument and the measurement. Therefore, it is now going to be that, and you are left with the units of decaliters. This right here is how you do a double-step metric conversion. Okay, just for sake of breaking this up, I'm going to end this so that it's all just metric, and I'm going to do another video segment on non-metric. Alright.